Hello students, in this lecture we will study about the Huffman algorithm. This is very important algorithm for that is using for the lossless compression. Means in text data we cannot bear a loss of even a single bit. Therefore we use lossless compression. But in case of audio, video or images, there may be some loss of the data. We cannot recognize the change between original image and some lossy image. In that case, we use JPEG, MPEG, and such type of algorithms. But in case of text data, where a single bit loss is cannot be bared, we use the Huffman algorithm. It is a lossless algorithm. Let us introduce about the Huffman algorithm. It was developed by David A. Huffman, and the Huffman code obtained from the Huffman algorithm is variable length code. Variable length code means the symbol or the character whose frequency is larger, means whose chances of occurrence is high, has less number of bits in comparison to those symbols or characters whose frequency is less. And it gives a prefix code, optimal prefix code, that is generally used for the lossless compression, means in the case of text data, as I have told you. So let us move to the definition of the prefix code. What do you mean by prefix code? Because Huffman code generates the prefix code. So first of all, we will discuss about the prefix code. It is a code in which no code word is the prefix of any other code word. It is also known as prefix free code. Prefix free means the any code does not have the prefix of any other code, or it is also known as prefix condition code, or it is also known as instantaneous code. All these are same. All these names are used for the prefix code. For example, some prefix codes are 0, 1. In 0 and 1, this is a code book in which there are only two codes, 0 and 1. And no code is prefix of any other code word, because 0 does not occur as a prefix of 1 and 1 is also does not occur as a prefix of 0. 1, 0, 1. Here 1 is not prefix of 0, 1, or 0, 1 is not prefix of 1. Therefore, it is also a prefix code. Similarly, third code 0, 1, 1. This code book also has two codes, and this code book is a, or this system is a prefix code, or this system gives a code which is known as prefix code. Similarly, 0 and 1, 0. Here also 0 is not the prefix of 1, 0. It is in the postfix but not in prefix. In this code book 0, 0, 1, 0, 0, 1, 0 and 1, 1, 0, 0, 0, you can check whether this code is occurred in the prefix of some other code. 0, 0 not occurred in any of the prefix format. Here 0, 1, here 1, 1, not 0, 0. Similarly, 1, 0, it is 0, 1, not 1, 0. If these two bits will be 1, 0, then it is not a prefix code, because it is also 1, 0 and 1, 0 here occurred also. Therefore, this code will not be the prefix code. But this is 1, 0 and this is 0, 1. Therefore, it is not a prefix of this code. Similarly, 0, 0, 1, 0 are not prefix of any of the code word, and similarly these two code words are also not prefix of any other code word. Therefore, all these collections or all these code books or all these systems are prefix code systems. Means this system will generate a code which is known as a prefix code. Now, let us discuss what do you mean by the non-prefix code. 0, 1, 1, 0, 1, 1, 0, 1. Here you can see the 0 occurs as a prefix in the code 0, 1. See the code 0 and 0, 1. The 0 occurred in this code as a prefix because 1 contains, before 1 there is a 0, and this 0 is also in another code word. Means 0 is a prefix of code word 0, 1. Similarly, 1 is prefix of 1, 0 as well as 1, 1, because here the 1 occurred before 0 and in this one occurred here before 1. Means this one occurred as a prefix for these two codes, 1, 0 and 1, 1. And similarly, in the second code book, 0, 1 is the prefix of code 0, 1, 1, 1. means before 11 there is a code 01, which is also another code word. Therefore, this is not a prefix code. Similarly, 11 and 1111. You can see that this code 11 occurs before this 11, means all these bits 1111, first two bits are the another code word, means this 11 is occurs as a prefix of code 1111. Therefore, it is also a non-prefix code. I have changed the color so that you can visualize easily. 0 is prefix of 01, so we highlighted 0, and 1 is prefix of 10 and 11. Therefore, it is a not prefix code. Similarly, here 01 occurs as a prefix of 0111, and 11 occurs as a prefix of 1111. Means all these systems are a non-prefix codes. Why the non-prefix codes are not preferred? The reason is that it can be explained better with the help of an example. Suppose we are using a code book which uses a code that are a non-prefix codes, because 0 and 0 occurs as a prefix of 01. Similarly, 1, which occurs as a prefix of 10. This code book contains 4 different codes, means with the 4 different codes, code words, we can generate code for 4 different characters or symbols. Suppose A is denoted with 0, B is denoted with 1, C is denoted with 10, and D is denoted with 01. Because there are 4 code words, means we can code for 4 different symbols. And suppose we have to code for the character or code for the word A, B, B, C, D. Suppose there is a word A, B, B, C, D, and we have to generate a code for this A, B, B, C, D using this code book. If we use this code book, then we can get A is replaced by 0, black, we have also shown a black color. B with 1, so blue and blue, B is replaced with 1. Similarly, another B is also replaced with 1. Similarly, C is replaced with 10, red color. And finally, D, which is replaced with 01 in the green color, shown in the green color. So for the code word, for the word A, B, B, C, D, we get the code 0111001. Now let us see what will be the problem at the receiver end. Suppose this ABBCD is received at the receiver end, not ABBCD, but the receiver will receive the code, which is 0111001. Now the receiver also has the same code book, and with this code book, if the codes are not prefixed, then the receiver can decode in many alphabets. For example, the receiver receives 0111001, so he can decode this 0 with the 1A. This 0 is decoded with A, and this 1 is decoded with B. This one is decoded another with B. This one is another decoded with another B. So triple B, A triple B. Now 0 means we can decode it 0 as A, another 0, so we can decode A. So receiver confused, either we have to consider these two zeros as two A's, or 001 is replaced with 0 with A and 01 with D. So there is a confusion. If we have to decode it, we can decode it in many different characters at different times. So some examples are given here: D double B double AB, A triple B double AB, or A triple B AD. For example, if we consider these two, not the single 0, but we consider these two bits 0 1, then we decode D. But if we consider only 0, then we decode it A. So there is also a confusion from first bit to last bit. So we have a different permutation combinations, and since we did not get any unique code, it means this is a wrong method of coding. Therefore, we are not preferring the non-prefix codes. Now let us move to the prefix codes. Means why the prefix codes are preferred. What is the reason why they are preferred? Now we have taken a code book which supports the prefix codes or which generates the prefix codes 00, 10, 010 and 110. Here no code word is prefix of any other code word. These are the four code words. Since there are four code words, it means we can code four different symbols. Suppose these symbols are A, B, C, D. We allot 00 for A, we allot 10 for B, 010 for C, and 110 for D. And again we have to code for the same A double B C D. Now we get the code A00 means for A we get 00, for B we get 10, so 10, another B, so another 10. C is replaced with 010, so this red color 010, and D is replaced with 110. So in the green color it is shown that 110. So A double B C D will be coded as 00, 1010, 010, 110. Now when this code word is received at the receiver end, the receiver doesn't get any confusion. He doesn't have any confusion. How? You can see if we read a single zero, there are two options. Either it is A or it is C. But as soon as we read another zero, we easily recognize that it is not the C, but it is definitely A. Therefore, these two symbols are decoded as A. Now we come to another bit, 1. When we read first one, there are the chances that it may be B or it may be D. But as soon as we receive 0, it is confirmed that it is B, not the D. So decode these two bits as a B. Now another 1 is received, and after 1 we just after 1 we receive 0. So it is another B. We have decoded it as another B. Next we receive 0. As soon as we receive 0, there are two chances, either A or C. But just after 0 we receive 1, so it is confirmed that it is C. Means the first 3 bits are decoded as C. Now we come to the last 3 bits. We receive the first bit 1, we read the first bit 1. Another one, just we receive two continuous 1 means it is a D. And 0 confirms that, 110 confirms that it is the D. So there is no any confusion. We can easily decode and decode uniquely. We get only single code. And we get the ABBCD, which was sent by the sender send. So this is the reason why we prefer the prefix code. Now we come to the Huffman algorithm, which gives us a variable length code. And there is a question: for the following symbols, find the Huffman tree, Huffman code, average code length, and we have to also decode a given code. 5 times 1, then 20, then 1001. The given list of symbols contains 1, 2, 3, 4, 5, 6, 6 symbols, and every symbol is given with its probability 0.00, 0.05, 0.10, 0.15, 0.20, 0.22, and 0.28. Now, first of all, to get the Huffman code or average length code, we have to first of all calculate the Huffman tree. So let us move to calculate for the Huffman tree. There are some steps to generate the Huffman tree. Step 1 is arrange the given symbols in increasing order or decreasing order of their weight. But it is not so much necessary. So just we move to the second step. It is the compulsory step where we have to create or generate a single node tree for each of the given symbol. For example, here 1, 2, 3, 4, 5, 6. There are 6 symbols. Therefore, we have to generate a single node tree for these 6 symbols. And we write the probability of each tree with the single node. Now, we have to combine the two trees of least weight. Weight means either probability or frequency. In this question, we have given a probability value. Therefore, we use the probability value. So you can see that out of these 6 symbols, the least probability is of symbols A and B, 0.05 and 0.10. Therefore, we combine these two symbols and generate a single tree. So these A and B are known as leaf node, and this node is known as intermediate node. The weight of this node is the sum of the weight of the leaf nodes. 0.05 plus 0.10 means the weight of this node is 0.15. Now again we continue this procedure of combining the trees until we get a single tree. So next, when we scan from left to right, we see that the least two weights or the least two probabilities are 0.15 and 0.15. Therefore, again we combine, this is the total probability, and we combine these two 0.15 probability trees. One tree contains two nodes and one tree contains single node. Therefore, we combine these two nodes. So 0.15 and this 0.15 is combined. So the intermediate node or the parent node has the weight which is equal to the sum of the weights of its children. 0.15 means the weight of parent node is 0.30. You can see that all the yellow color nodes are the leaf nodes and the pink color nodes are the intermediate nodes. Now again scan from left to right and find two nodes that are of least weight. So when we scan this time, we get D and E of the least weight nodes, least probability nodes. So we combine, you can see there, this is the last symbol, this is the last, I copied it here, and we combine D and E. So we get 0.20 plus 0.22 means 0.42. Now again scan, every time the trees reduces by 1. Here are 4 trees, now here are only 3 trees. Again we scan from left to right and we find that this tree 0.30 weight and this tree F 0.028 probability has the least weights. Therefore combine these two. It is a general notation that we out of these two 0.30 and 0.28 F has the lesser weight. Therefore lesser weights are kept in the left directions. It is just a convention. So this is the, we have combined these two. F is 0.30 and 0.28. So F will be the left child and whole this assembly will get to the right side. And weight of this node is equal to the 0.28 plus 0.30 means 0.58. Now from 3 nodes we get just 2 nodes. Now there are no other option. We have to combine these two trees and we get the single tree, which is the last step. So we combine. You can see this has the least weight, lesser weight in comparison to this. So this node is assembled to the left direction and we get the this is the our Huffman tree, but it will be called a Huffman tree only after when we assign left edge with 0 and right edge with 1. Every left edge is assigned a 0 weight and every right edge is assigned a 1. 0 1 0 1 0 1 0 1 0 1. This is known as the Huffman tree, which is required by the first part of the question. This is the answer of that question. Now when we get the Huffman tree, we can easily calculate the code for each of the symbols. Here you can see that every character is as a leaf node in this Huffman tree. Now, how the code is generated? Let us see. Suppose we have to generate code for the A. Every time we have to generate the code for any symbol, we have to move from root node to that symbol. If we move from root node to this symbol, then we have to travel the path 1, then 1, then 0, then 0. This path. So we get the code 1100. Now we have to obtain the code for B. So to reach the B, again we have to move to the root node, and from root node we have to travel to the leaf node. So we can move to the B as 1, 1, 0 and 1, this path, and we get the code 1101. Now we have to find the code for C. We can get the code for C by moving from the root node via 1, 1, 1. So this is the path and we get the code C. And next we have to find the code for D, which will be 0, 0. For E, we get the code 0, 1. For F, we follow this path 1 and 0 and the code is 1, 0. So we can give a list of codes from A to F as 1100, 1101, 111, 00, 01 and 10. You can easily observe that the symbol which have least probability have higher number of bits, but all those symbols which have the higher probability, for example F or E, out of all these symbols, these two symbols or D have the higher probabilities. Therefore, for every higher probability symbols, we get the least number of bits. It means if they occur more frequently and take less number of bits, then we can compress our data to a more extent. Now this is the final table. These symbols and probability we have already given in the question. We have calculated the Huffman code from the Huffman tree, and here we write the code length. This contains 4 bits, so we write the code length as 4. This also contains 4 bits, so we write here 4. 3 bits, so write 3, and these all have all three last symbols have the 2 bits, therefore we write 222. Now, if we have to find the average code length, then we have to multiply and sum the probability of each symbol with its code length, probability of B and its length, probability of C and its length. And similarly from A to F, we have to sum all these products. So the formula of the average code length will become summation of probability multiplication of multiplication of probability into length for ith symbol. Means I, first value of I will be A, then B, then C, then D, then E, then F. So we combine 0.05 into 4 right here, plus 0.10 into 4, plus 0.15 into 3, plus 0.20 into 2, plus 0.22 into 2, and plus 0.28 into 2. Now we sum these, multiply and sum these equation, and we get the 2.45. The average code length is expressed in the bits. Therefore, we find that on an average, every symbol requires 2.45 bits, because some requires 4 bits, some requires 3 bits, some require 2 bits. So average lies between 2 and 4. So this value will be 2.45. Now, the last part of the given question will be was the we have to decode the 5 times 100 So how we can decode using the given Huffman tree? The procedure of decoding is very simple. We have to just read the bits and follow the tree. So how can we do this? We can see in next slides. This is the code that we have to decode, and this is the tree that we have obtained as a Huffman tree. So read the first bit. Read, we every time we read any bit, we change its color from blue to red. Read 1 and follow the route to the path 1, towards the path 1. Again we read 1 and we follow the 1 path. Next we read 1 and we follow the 1. And in this way we get the leaf node. So every time we have to process from the root node and read these bits, and this bit is being read until we get any leaf node. Since we are on the leaf node C, means first 3 bits are for the character C. So the decoded symbol is C. Now again we move to the root node and again start the reading the remaining codes. The next bit is 1, we have shown in green color. So we follow the path 1 in the Huffman tree. Another bit is also 1, so we again move towards 1. And now the third bit is 0, so we move to the 0, but still we have not reached to any leaf node. We have to move until we get any leaf node. We read another 0 and we move to the leaf node A. Means these 4 bits 1100 is used for the character A. So we decode these 4 bits as A, and the decoded symbol we have obtained is CA. Now we read the remaining bits. We read 1 and follow the path towards 1. 0, so we move towards 0 and we get a leaf node, and which is equivalent to F. So we decode 10 as a F, and To the total decoded symbol is CAF. Now finally we read the remaining 2 bits. Out of these 2 bits we read 0 and follow the 0 path, then 1, and after reading these 2 bits we get the symbol E, which is the leaf node. So we decoded these 2 bits as E. So in this way we have scanned the entire code, and what we decoded is the symbol, is the word cafe. So this is the answer of the last part, means the code 5 times 1001001 is decoded as cafe at the receiver end. Here you note that if in place of probability the frequency is given, then we have to follow the same pattern. I've also added one question which is based on the frequency so that you are not in any confusion state. For example, here we change the style of the question, and now the question is we have to draw the Huffman tree for any given quote, and this quote is given by Bob Marley. The quote is love the life you live and live the life you love. So we have to first of all identify all the different symbols that are used in this quote. The different symbols that are used in this code are L, O, V, E, T, H, I, F, Y, U. And the frequency, when we scan this code from left to right, from first character to last character, and count the frequency of each of the used symbols. For example, L is used 6 times in this code, and O is used 4 times. Similarly, V is used 3 times. V is used actually 4 times. We have to update this value. And E is 8 times. Similarly, T is 2 times, H is 2 times, and all the other are counted and written here in the form of a table. Now, the same procedure we have to follow. We have to generate a single node tree for the each of the symbol used. So we generate the tree for L, O, V, E, T, H, I, F, Y, U. And we have written the frequency in place of, in the last question we have given the probability, but in this question the frequency is given. Actually frequency is also not given, but we have to find out from the given code. Frequency means the number of occurrence of that character in the given text. So LOVE 644 822 4222. Now we have to combine the two least weight symbols. Here we find the least weight as 2, but this least weight is of 4 symbols T, H, F, Y, and U. So we can pick any 2 of them randomly. Suppose we have picked Y and U. So we combine these two, Y and U, and make a single tree, as you can see in the below diagram. The weight of these two are 2 and 2, means frequency is 2 and 2. Therefore, the parent node contains the sum of these two frequencies, 2 plus 2, 4. Now again scan from left to right and find again the least weight two trees of least weight. Since the least weight value is 2 and it is of 2 contains 3 by T, H, and F. Therefore, we can pick any 2 of them. Suppose we picked T and H just because they are close to each other. So we again combine them in the same manner, and the remaining trees are left as it is. Now again scan from left to right. This time the least weight is 2, but it is of only F. So we have to combine it with any of the next higher weight symbol. So we can do, one symbol will be F and another symbol will be either O or V or I, or these two may also be combined with F, but these two are close to each other, so we combine these two and we get the, when we combine these two we get the weight 6. Now when we scan from left to right, the least weight that is existing is 4, and 4, the weight 4 is for the tree O, V, and this tree and this tree. These are close to each other, so we combine O and V. We can combine any other two trees also whose weight is 4, but we combine O and V. Now we get the 4 and 4, so weight of the parent node will be 8. When again we scan from left to right, we see that the least weight is 4, and this is for these two trees. So we copied in this, just the last diagram is copied as the first diagram, and we have to combine these two because these have the least weights. When we combine these two trees, we get the weight 8, and these 3 are copies as it is, and this 6 is also copies as it is. Now when we scan again, the least weight is 6, which is of the L and this last node. First and last have the least weights. So combine these two, we get this one. The total weight is 12, 6 plus 6. And these 3 trees are just copied to downward. Now the least weight is 8. So we can combine any 3. We can select any 2 of these 3. Suppose we select the middle one. And when we combine, we get the weight 16. Now the least weight is 12 and 8. So combine these two, 12 and 8. 8 has the lesser weight, therefore it will become as a left subtree, and 12 will become the right subtree. And the total weight 12 plus 8 is equal to 20. Now the only 2 trees are remaining, and we have no other option left. So we have to combine these 2 trees. 16 weight is lesser though, so it will goes to the left direction, and 20 will go to the right subtree. So combine, and this will be our final Huffman tree. Just add 0 and 1 to each edge. Every left edge contains 0 and every right edge contains 1. So this is our final Huffman tree which is required in the question. Now the code for each of the symbols can also be obtained as, every time if we have to find the code for L, means we have to move from root node to the, until we reach to the node L. So 1, 1 and 0. So this is 1, 1, 1, 0. Now if we have to find the code for O, we have to move from the root node to 0, 0 and 0. So this is the code 0. Again you can analyze that the symbols whose frequency is higher, for example L whose frequency is 6, E whose frequency is 8, have contains the least number. We can see that E has the highest frequency 8. So we get, means the chances of occurrence of E is higher. Therefore, we have to replace the E with the least number of bits. So the least bit is 2. And as next symbol is 6 and 4, frequency of the L is 4, frequency of O and V, L is 6 and O and V 4. Therefore, we get an extra bit in these codes. And for those symbols whose frequency is very less, 2, 2, 2, we get the highest number of bits in 4. 10011 means 4 bits, 1010 means 4 bits. It means those symbols whose chances of occurrence are very less, if we code them with larger number of bits, there is no problem. But those symbols which are mostly occurred or most frequent symbols must have least number of bits. Otherwise, we cannot reduce the size of the code. We cannot save the memory. So thank you for watching the Huffman algorithm video. I hope you understand the concept. So please like, subscribe, and you can also send the feedback on the KBD Edu channel at gmail.com. So once again, thank you for watching.